Good morning to one and all. So, welcome to the online training workshop on computational density functional theory. I am Dr. C. Ravikumar, working as a lecturer in physics, Thandai Periyar EVR Government Polytechnic College, Vellore, Tamil Nadu, India. So, I hope during this pandemic period, everyone is safe and healthy. Whatever comes to us, the learning, it will not be stopped. We learn till the end of our life. So as a part of it, I have started this online training workshop on computational density functional theory. So before we get into the session, a thought for the day. So most of you might be knowing him. He is Swami Vivekananda, a spiritual leader. He always insists on we are what our thoughts have made us. So we have to take care about what you think. In our mother tongue Tamil, we call it as Ennambol Valkai. Words are secondary, but what we think, our thoughts live forever. They travel so far and reach many people. So we should have a positive thinking, a positive thoughts, so that we can enjoy our life happy. So this is a relationship between the theory, computation, and experiments. In olden days, only we have two parts. One is the theory and another one is the experiment part. So the scientists, they develop the theory and the experiments are carried out to verify that theory. Or from the experiments, the theories were developed. Okay, so only this is the two-way process. So this theory, it is useful to develop the models, hypotheses, predictions, and even we can derive the conclusions from that theory. And using the experiments, we can do measurements and we can observe. Observations can be done. Even we can collect the data, and to test the hypothesis, to test the theory, the experiments are much useful. But in this modern world, the another one part is also included in this circle. That is nothing but a computation, simulation. So what is the purpose of this computation? This computation is used to stimulate the models based on the theory, and it is used to test the hypothesis and to do the observations, visualizations, nothing but a virtual experiment. So that is the purpose of this computation, the simulation part. So computer simulation and modeling, which is the principal tool in the computational chemistry. So there are two things are there. One is the computer model and another one is the computer simulation. Computer model is nothing but which involves the expression of the system that is to be studied in terms of some quantum mechanical equations using the algorithms. But computer simulation is nothing but running the computer-based program that contains these equations, these algorithms. So simulation is therefore is the process of running a model. What we actually do in this real-time system, we make model, and from the model we make model systems, and with the help of that model systems we construct some approximate theory or we can perform the simulations. From the simulations, the simulation results are obtained. From the approximation theories, the theoretical predictions, okay, we obtain. So using these two, we can come to the conclusion and we can compare and we can improve the theory again, once again. In the another way, from the real system, we can do the experiments, and based on that experimental results, we can compare and improve the models again. So this is the process of building the computer model, and which explains the interplay between the experiment, simulation, and as well as the theory. So computational models, the molecular modeling, which is the emerging field, okay, and also it is the subdivision of the computational chemistry, which focuses on calculating the behavior of individual molecules within the chemical structure or what are the compound we synthesize. Molecular modeling is classified into three categories that are nothing but ab initio methods, semi-empirical methods, and molecular mechanics. So the types of models are listed here. That list is according to that from most to least accurate. So the first one is the ab initio method, which uses the Schrodinger equation, but we use some approximations. But in the case of semi-empirical methods, which is using the experimental parameters and the extensive simplifications of the Schrodinger equation, is carried out in the case of the semi-empirical model. Molecular mechanics doesn't use of the Schrodinger equation. So among these, the ab initio methods is considered to be the very accurate and the consistent predictor, which is based on the quantum mechanics. DFT is also comes in that ab initio model only. A computational quantum mechanical modeling method that is used in physics, chemistry, and almost in all interdisciplinary sciences in order to investigate the structure, properties, electronic structure, okay, so many properties we can carry out using this DFT calculations. In 1964, Hohenbeck and Kohn introduced this density functional theory. The DFT calculations allow the prediction and calculation of the material behavior basis on quantum mechanical considerations without requiring the higher order parameters such as the fundamental material properties. DFT has been a very popular calculations in the solid state physics field since 1970. However, DFT was not considered as the accurate enough calculations in quantum chemistry till 1990 because of that methods. When the new approximation methods are used in the theory, it greatly refined the better model and the exchange and correlation interactions, and most of the researchers and scientists were started using that DFT. Computational costs are relatively low when compared to the traditional methods. So DFT functional theory, density functional theory is much popular nowadays. So these people are the creators of this density functional theory, the fathers of DFT, Walter Kohn, okay, and his postdoctoral fellows, Hohenbeck and also Shah. They introduced this density functional theory in the year of 1964 and 1965. The main focus of DFT is nothing but electron density. In regular quantum mechanics, it deals only about the wave function. But in the case of the DFT, the electron density is given more important. Why? Because the energy of a molecule depends on the position of electron density, and the electron density gives the probability of locating the electrons in a molecule. It involves using the probability density functions of the electrons in a molecule to determine the other properties of that molecule. When compared with the other computational techniques, DFT has become the most widely used technique in recent years for determining the molecular structure properties because of its less challenging computational tool, quicker results, and good agreement of results with experimental. There are so many density functional methods are available: B3LYP, B3P86, B3PW91, BH and H, BH and HLYP. So many models are available. One of the popular DFT method is B3LYP. Whenever you see any research paper published in reputed journals based on the density functional theory, you could check it, okay, that is done by B3LYP. Why? Because B3LYP is nothing but it is a hybrid Becky 3-parameter Lee-Yang pair correlational function, which is the hybrid functional of exact Hartree-Fock exchange with the local and gradient correlated exchange, and correlation terms as the first suggested by the Becky. In chemistry, there are so many basis sets are available. Basis sets is nothing but it is the group of mathematical functions which is used to describe the shape of the orbitals in the molecule. Each basis set is a different group of constants which is used in the wave function of the Schrodinger equation when we solve it. Atomic orbitals are the basis functions that have this property, and it is also available in two forms. One is the Slater type orbitals, STO we call it. Another one is the Gaussian type orbitals, GTO. The accuracy of the calculation is dependent on both model and type of basis sets what we use it. When we consider the larger basis sets which will describe the orbitals more accurately, but it will take more longer time to calculate it. So this is that some examples of this basis set. You could see 321Z or 6311G, 631 plus G of D, 6311 plus G of D comma B, P, which we will be using while we are performing that DFT calculations. So this 3, it represents the number of Gaussian functions summed to describe the inner cell orbital, that means the core orbital, and these explains about that valence orbitals. Okay. So this 2, it represents the double zeta function, and this 3, it represents the triple zeta function, and this part, it explains about the polarization functions, and this is nothing but it is the diffusion part. So many basis sets are available. Most of the time we always have this question in our mind: which one of the computational method will provide output near to the experimental results? I think many of you are having in your mind the same question. The answer is there is no golden key. Okay. The choice of appropriate method, it depends strongly on the particular system of interest and the properties you are interested in. Unfortunately, there is no golden key, as every of these methods has its own limitation, its own disadvantage, its own advantages, which is behind that physics and mathematics, which is used to approach and develop it. So, based on your structure, based on what properties you are interested, you have to appropriately select the computational method. Even we can think about this also. Is computational simulation is necessary? Because experiments have its own limitations under certain circumstances, like collecting the samples and what type of techniques we use it, okay, how we get the signals and everything. So that many physical properties, it cannot be measured accurately because of that conditions. And microscopic process, the growth and phase transition mechanism, okay, all these things we cannot understand only based on the experiments. Okay, so many properties cannot be understood by experiments directly. That is why we need this quantum computational simulations. What are the advantages of these simulations? So we can study the behavior of the system without building it. So you no need to synthesize any compound. Only you can build that compound, build that chemical structure, and you can perform the DFT calculations. You will get the results. After analyzing that results, you can improve your structure. After analyzing that bioactive properties of your structure, okay, you can improve your structure, which will become a perfect drug in future. So you no need to build any system. Okay, so only you have to build a structure, and based on the structure, you can do the computational simulations and you obtain the results. Okay, and analyze the results whether our structure is useful for any industrial or biomedical applications. The results are accurate in general compared to that analytical model. Most of the computational methods are providing that accurate results, very close to that experimental point. It is useful to help in find unexpected phenomenon behavior of the system. So we don't know experimentally if we do some calculations, what will happen, that we don't know. But in simulation part, we can do that. We can apply the force field, okay, we can change the environment, all the gimmicks we can do it in the simulation part, and we can study about it. And it is easy to perform what if analysis. That is very, very important. Okay, if we do that, what will happen? That we can analyze. If we change this model, what will happen? That we can analyze. So computational simulation is much necessary nowadays. To do that computational simulations, the quantum chemistry computer programs are used, and these programs based on the Hartree-Fock theory or post-Hartree-Fock methods, and also includes the density functional theory, molecular mechanics, semi-empirical, and so many methods. The list of quantum chemistry and solid-state physics software is given in this link, and I have provided that the same thing in the description part also. Okay, so let us see that. When you go to that Wikipedia, okay, so here you can check it. the list of quantum chemistry and solid state physics software. So the entire list is given, which is free and academical and commercial, all type of licenses. Okay, so you can select based on your interest, based on your capacity. You can go for free version, or you can apply for academic license, or you can purchase. And in which language those are coded, and what are the basis sets are used, and what methods are used in that computational software. Everything is given in this list. You could check it. So many popular, say this quantum espresso, okay, Gaussian, which is one of the top commercial DFT software, and Jaguar, it is a Schrodinger software. So many softwares are available. Orca, Gammas, VAST, AMBAC, okay, that is a Firefly. Formerly it is called as a PC Gammas. These softwares will provide almost accurate results compared to the experimental results. So whenever you go through any research papers, you have to compulsorily note it down, okay, what type of methods they have used and what is their structure, whether it is the organic or inorganic or nanostructure, and for that what type of methods, DFT methods they used, which software program they were applied. Everything you have to note it down, and you have to compare with your structure, and based on that you can select which software is useful and which method is useful. Okay. So using the DFTK, what are the properties we can calculate? There are number of properties we can calculate. We can calculate the structural properties of the compound. We can calculate the electronic properties. We can calculate the magnetic and vibrational, the spectroscopic properties, even optical, thermodynamical, many properties we can calculate using the DFT. So for your structure, what type of properties you are expecting? First, you have to decide them. For that properties, which is the suitable basis set, suitable computational DFT model that you have to choose it. Based on that, we have to perform the calculation. So before going into that DFT calculations, we should draw our structure. So for that, this chemical structures drawing softwares are used. There are so many softwares are available, and some of the popular and user-friendly softwares we are going to deal it today. In that, Avogadro, MarvinSketch, and even ACD is also available. Okay, so these are free. Even academic licenses are also available. All the links of these softwares are given, okay, in the description part. You can check that. Okay, so let us go to the training part. So the first one we are going to see that MarvinSketch software. So MarvinSketch, okay, it is nothing but it is a full-featured the chemical editor, and it is one of the intelligent desktop toolkit to build, to draw, edit, even to publish, render, import. So many applications are available in this MarvinSketch. It is free, okay, for individuals. Even you can apply for academic license, and also for non-commercial use you can do that. So in that Marvin shoot, okay, there are so many add-ons are available. That is MarvinSketch, which is used to create and design. Marvin View, to view only the molecules. Okay, and Mol Convert, it will convert between chemical file formats like OpenPep. So let us start with that MarvinSketch. So download the MarvinSketch from this link, okay, and install in your computer. So once you open that MarvinSketch software, the main window, it will be appearing like this. So the regular tabs are available like File, Edit, View, Insert, Atom, Bond, Structure, Calculation, Services, okay, everything. So this side all the important tools are given, and this side all the compounds lists are given, chemical elements lists are provided here. Okay. So here you could check it. So import name, import image, okay. So export to image, find structure online. We can find the structure using the chemicalize or ChemSpider or PubChem. So initially, before drawing any chemical structure using these tools, already there is the library available in this MarvinSketch itself. So with the help of that library, I am going to show you how to insert a chemical structure. So the template. So you have to go to the insert, and in the insert, the template library manager you can select. So here you could see so many categories. The generic categories are available, even so many different types of rings, okay, phenyl rings, and different types of amino acids are available here. All types of amino acids are here, and conformers, heterocycles, which is okay, mostly used while drawing and chemical structures. Pyrazole, furan, so many are there. So vitamins, all. So in this, you select any one. Namely, I am selecting that vitamin B1. Once you select it, when you move to that the main window, then automatically you can see that okay, the structure is pasted here. Now I move. You select anything, okay, it will be automatically. I am going to paste it here. Select and place it, and I will place it. Okay, so close. So till you press the escape button, that structure it will be okay, always visible. Once you press that escape button, only the arrow marks it will come. And if you want to select any structure, you can click this button. It is the rectangle selection tool, or the lasso selection, or the structure selection is there. Structure selection, when you select it and when you press on this, automatically the whole structure is selected. Okay. So when you hover on any structure, so you could see the dotted rectangle is appearing. When you move little bit closer, like a gear, okay, when you move it, okay, exact square is appearing. So when a square appears, by pressing that left button of the mouse, you can move it. You can move any chemical structure to whatever the places you need. Okay, come little bit outside. Now in the gear structure, you press your left button of the mouse and you move it, it will be rotated. So it is the rotating option. You can rotate. Okay, so this is one of the important. So without drawing any chemical structure, with the help of this insert and template library, you can paste many structures here. Then you have to press escape, then only the empty cursor it will be appearing. Remaining okay, the general thing, if you know the Microsoft Office, okay, like that only, Control A, it will select all the molecules, Control C, copy, Control V, paste, Control Z, okay, that undo, redo, everything is same. So now I have selected all, and I am entering the delete button, okay, it will be deleted. Now the next important thing is preferences. So you have to go to that edit, and there you click the preferences. Okay. So here you can change the default the structural properties. in the structure, okay, it will be highlighting the valence error if you need it, or you can skip it. Okay, so like this, the text when you are writing the chemical compound name, okay, which font you need, which style, which bold, okay, everything you can modify it. So this is one of the important menu. So in order to access this menu, you have to go to that edit and their preferences. So what I'm explaining, with the help of that, 90% you could draw the chemical structure. Okay. And still so many features are available in this one. I'm not going to explain all the things which is mostly used by many people. I'm going to tell you that one only, because today we have to see MarvinSketch and Avogadro and as well as the GaussView. Okay, three I have to complete it. Okay, so because of that, I'm explaining mostly used functions. The next one is the structure menu. This is one of the important menu here. So to explain that, okay, so I will be pasting some structure here. So vitamin B9, I'm going to paste it here. I have pasted, I closed it, I press the escape button. Okay, now I'm moving this here to the center. Now go to that structure. So you can clean this structure in 2D model. So what is the purpose of this cleaning? I'll explain it. Okay, or you could structure to name. The IUPAC name is generated for your structure with the help of this. So you can copy it and you can paste it in any text editor like MS Word, Notepad, in anything you can do that. Okay. The name can be generated, or from the name you can bring the structure here. I'm going to import it. So from the website, okay, it will be imported. Either you can convert a structure to name or name to structure with the help of this structure option. Okay, so these two are one of the important things. Coming to that calculation, elemental analysis. So when you press the elemental analysis, okay, there another one pop-up, it will be appearing. It will be asking you what type of calculations you needed. One is the molecular weight, exact molecular weight, formula, okay, all these things. So which one you needed, those only you check it and you press OK. Okay. So the properties of calculated elemental analysis are performed for your structure. Whether you have synthesized it or imaginally you have drawn, for that structure the elemental analysis is calculated. So this will be mostly used. Then protonation and partitioning, solubility, charge, NMR. You can predict the carbon NMR and hydrogen NMR for your structure. But in a free version, this will not be available. In the academic license and as well as the commercial one, it will be available. And confirmations, even the geometry, topology analysis, everything you can do that. The polar surface area, molecular surface area, okay, the H-bond donor, H-bond acceptor, refractive you can calculate it, structural frameworks you can calculate it. So all these things could be done with the help of this calculation tool. So now select it, delete. Now I am going to show you how to draw a small synthesis scheme. In most of the research papers, the synthesis scheme is drawn. Which software they have used, okay, so many doubts we may be having. With the help of this MarvinSketch, an excellent synthesis scheme diagram can be drawn. So I am not a chemist, so I am not going to follow all the chemical rules here. Simply I am going to take the structures and I am going to show you how to draw the chemical scheme, synthesis scheme. So for that I am taking a benzene here, and these tools, it will be giving a single bond or double bond or triple bond, whatever it is, and this will draw a chain. Okay, so chain, you select it, chains can be drawn. Okay, and you can change the atom. So this I'm going to keep it as oxygen, and here again I'm going to place a double bond and one more oxygen I'm going to add it here. So like this. Then another one reactant, I'm going to add it here, maybe Cl. Okay. So you place it here, and this one is a straight arrow. You click this and place a chemical arrow. Once it is done, you could see automatically the plus sign is added. Okay, it automatically predicts that you are going to draw some chemical synthesis scheme or some chemical reactions. Okay, you are drawing, automatically it predicts, and the plus sign it will be given here. Okay. And then so this is A and B. Okay, these two react and it will give the product for us. Okay, so that what I'm going to do is Control Z. I'm going to select the structure. I have selected. Control C, I copied. Control V, I pasted. Here I'm going to paste it. Okay, like this. So this, I think somewhat here maybe Cl. You don't think about the chemistry behind this. Only you think about how we can draw this. That's it. Okay. Rectangle selection tool I'm taking. I have selected all. And even you could go to the edit menu, you could align it okay, in whatever the orientation you need it. Left orientation, see like this, align, center vertical, all the three, centers horizontal. So this will be nice. So this, a simple chemical synthesis scheme you can draw. You can move it. Automatically the plus sign it will be moving along with you. Wherever you want, you can paste it here. And once it is drawn, what you have to do is you can export to image. You go to file, export to image, and in which folder you want to save it, you select that folder. Okay. And example 1 I'm keeping. So what are the file types are available here, you could check it. JPEG, okay, all the normal file types, image file types are available here. See, like this, save it, and it will be asking the relative scale. If one is there, okay, in that the size of that image it will be somewhat smaller. I'm going to give some 2.0. Okay, and the scale it will be automatically changed. The height and width it will be changed. The compression level it will be here. You give it save. It is saved. Now I'm going to show you the file type. So neat. Even when you enlarge this also, the image it will be clear, because in most of the journals, okay, they will be asking clear images for your publications. So it will be more clear. So you can do this in this way. And another one important feature of this Marvin sketch is nothing but we can draw that R groups diagrams. Okay. So the chemistry peoples will be knowing about what is that R group. So let me tell you how to draw them. So here I am taking a benzene and single bond. I'm going to add some triazole moiety. So for that I will be taking that nitrogen. So we will draw 1, 2, 3 triazole. So like this. In case if you change the bonds here, the single bond to double bond, okay, so there will be a red circle around this atom. This red circle represents that there is the error in the valence. So valence error happens to the structure. Okay, so you have to rectify that. So now you select this, go to that structure and clean. See, now you could see the structure is cleaned in 2 dimensions, and even you can clean in 3D also. See, in some of the papers, okay, you might be seeing this type of structures. three-dimensional structure. You can rotate it, you can move it. Okay, so now I am going to add R group here. Here, let it be like this, and I'm going to take chlorine, bromine, and somewhat like this. You select all these things, and in the keyboard you enter R1. You have to select, and in the keyboard you have to enter R1. So in the cursor also the same R1 it will be there. So you can go and you can fix in which atom that R1 group is going to add. That you can do it like this. Once it is done, what I'm going to do is I'm going to select the structure and go to that structure. This Marvish enumeration, this is important function, important feature of this MarvinSketch. So this will generate all the enumerations using these. So you press OK. So for that you need license. However, in evaluation mode it will be done. See, now you could check. So what happened to this structure? These groups are attached and the chemical structure is drawn. So in this R1 place, in the HCl, Cl is added and bromine is added. Okay, in the hydrogen sulfide, it is HS. You don't think about the chemistry here. Okay, so it is added. So that Marvish enumeration is mostly used to get the chemical structures with the help of that R1 groups or R groups. Normally, to call it as R groups. You can use this feature, and you can draw any structure. Okay, so let it be. I will delete this. I think this will be more clear. And after I draw this, you can right click your mouse and add to my template. Even you can add your structure to the template library. Why do you have to do that? Whenever you are working with some compounds, okay, so again and again you no need to draw the structure here. Directly from my templates you can paste it, okay, your structure. So once you draw your structure, okay, you don't forget to add it into my template. So it will be there. So you have to select that structure and right click it and add it to my template. So I explained how to export this to image, and now I will explain, okay, how to save it. Okay, once you draw the structure, you go to that file, then save. Okay, so here the file types you can type. Okay, you can save it as a mol file, okay, or SDF or SD. Even so many smiles, inchi, okay, PDP files you can save it. Mol2 type files you can save it. Gaussian input format you can save it. Okay, in our workshop this is important. So you have to draw your structure and you can save it as the Gaussian input file. So example 1. Now you save. So your structure is saved. And in the next part we will open that structure in Gaussian software, okay, in a DFT software, and there we will perform the DFT calculations. So you today itself you download this and you try this, the MarvinSketch. Okay, so definitely you will love this software. I hope friends, okay, you could do the maximum part using this MarvinSketch with this little explanation. Okay, so now let us go to the another software, this Avogadro. This Avogadro, it is an advanced molecular editor, so which is mostly used in a cross-platform, okay, in computational chemistry, molecular modeling, bioinformatics, material science. See, you could check all these figures. These are drawn with the help of this Avogadro. See how beautiful they are. Okay, so many nanostructures, nanotubes, organic, inorganic, DNA, okay, RNA, proteins. So many structures are drawn with the help of this Avogadro. When you compare Avogadro with MarvinSketch, two are different. Okay. So Avogadro is useful for many applications. The MarvinSketch to draw the chemical scheme, okay, chemical structure, and to perform the basic calculations. Okay, that's all. But in Avogadro, you could perform most of the things. So let us see that, and you could download. Okay, and even you can apply for. Sorry, this is completely free. You can download it. So once you download it and install in your system, and when you open that Avogadro software, okay, the window it will be appeared like this. So the same menus, file, edit, view. This is useful for building structures. Okay, even a nanotube builder is there. You can build a nanotubes, and you select, and so many extensions. As I have told you, that Avogadro software is useful to perform DFT calculations, especially with the help of many softwares. This will generate the input files for these many softwares: Gammas, Ab Initio, Dalton, Gammas UK, Gaussian, Malpro, Mopac, okay, QChem, Lamps. These are mostly popular software to perform the DFT calculations. That Orca, okay, so all these things. You can perform the molecular mechanics, basic molecular mechanics calculations here itself with the help of this Avogadro itself, and you can optimize the geometry with the help of this Avogadro itself. Okay. And even crystallographers are using this Avogadro software, okay, to build the crystal structures. You can add the unit cell, you can import crystals from the clipboard, okay, you can build space groups, and so many things can be done with the help of this. These are the regular buttons for new, open, save, and close. Okay, no need to explain those. You know it already. These tools, let me explain a little bit later. So before that, one of the most important feature of this Avogadro software is import. So you have to go to the file and you click import. Okay, so in that import you can directly import the molecular file, or you can even import the trajectory file after the MD simulations. Okay, so in future workshops, okay, I will be organizing the molecular dynamics workshops also. So I will send the flyers for that. And even you can import crystals. You can fetch PDP files directly from that website. So I'll explain. 6LU7. So most of you might have heard this PDP. Okay, so one of the COVID protein. When you click it, then you have to wait for some time. See now, that PDP structure is automatically pasted on this main window. So with the help of that mouse, you can enlarge and reduce the size. You can do all these things. New one I will open. This let me close. Similarly, you can fetch it by using the chemical name. If you know any drugs chemical name or any compound chemical name, you can paste it here and automatically it will be imported to that main file. Okay, so which is a popular drug for antifungal medication, fungal diseases. So wait for time. I think network is good. Yeah. So you should have a proper network to do that. Okay. So the drug compound is pasted on your main window. By pressing that left mouse button, you could rotate it. Okay. Right mouse button, you could move it. So all these transformation activities you can do it with the help of this. See how beautiful it is. The publication purpose it will be okay, wonderful. The more colorful diagrams can be obtained with the help of this Avogadro software. Then similarly, the file, the last one is you can fetch directly from URL. So any website from the website directly that molecule can be downloaded with the help of this. And the next one is export. You can export this to that image file. You can export it. So you select where do you want to save it. The same thing, JPEG, PNG, BMP files. So JPEG, Avogadro tutorial. I'm going to example 1. Save it. Sorry, this is already in SDF mode. So save as. Even you can save it as a PDP. Okay, the Gaussian, gammas. So say mol2 in XYZ format. You can save it this. Then the next important thing is the extension part we have to move. So in that extension, okay, let me explain a few things. The first one is the molecular mechanics. So calculate the energy of this. See, the energy of this molecule is shown here. The molecular mechanical calculations are performed using okay with this inbuilt Avogadro software. 289 kilojoules per mole. Now these tools are very important. This is a build tool, the draw. You can draw the chemical structure. Okay, and this one is for navigation purpose, and this is for bond centric manipulation purpose, and this is manipulation tool and selection tool, and this is auto rotation tool. When you click this auto rotation tool, okay, X rotation, Y rotation, you define it, you can stop. So you can capture the video with the help of this. So you can change the directions here. Okay, stop it, close it, and this is the most important tool, auto optimization tool. You press this auto optimization tool. In tool settings, when you go it, this will be there. You can apply the force field for your structure. By default, the UFF, universal force field, okay, it is selected by default in Avogadro. And you might be heard MMFF, Merck molecular force field 94 or Merck molecular force field 94S, okay, which is used popularly. So in UFF, I am going to apply the force field, the universal force field, and you can select the fixed atoms are movable or the ignored atoms are movable. Okay, so you can select any atom. So that atom you can okay change the radius, you could change the label, you could change the color. Okay, everything you could do it with the help of this. So in the view projections mode, you can see it here that you could change it. Background color you can change it. Okay, so to whatever the background you need it, you can change the background color. For that you have to go to the view. Okay, so now normally in publications, okay, we'll be doing a white background. So white, let me choose here. Okay, so in auto optimization tool, here you start it. When you start it here, you could check it. The calculations are carried out. The energy, see that DE it should reach to 0. Till that the optimization it will be carried out. See now what I am doing, I am dragging some of the elements. Now you could see how the structure is relaxing by itself. The optimization process is carried. See, how beautifully the optimization is carried out with this Avogadro software. So once the DE becomes 0, then automatically the calculation it will be stopped. It's okay. So now I am forcefully stopping this optimization till it is moving. So it is getting optimized. Let us wait for some more time. Now you could check that the DA value it reduces to 0 automatically, and the energy, the ground state energy is being calculated. Okay, see, gradually it is going to 0. Once it is reaches to 0, the optimization process it will be stopped automatically. See, now there is no change in that energy to that much. Only very few change in that energy. Okay, we could observe here. So let us stop here. Okay, you expand, you can zoom it. And next one is, this is the measuring tool. So you could measure the, okay. So here the bond distance it will be shown here, the bond angles. Okay. So 1, 2, 3, 4, the dihedral angles. So everything you could measure with the help of this measuring tool. So this is that measuring tool. Okay, and this is the aligned molecules. So if you draw 2 or 3 molecules, okay, in this main window, then it will be aligned. That you could do it. So now I will open the new window. Let me close it. I'm going to save it. So now let us see how to draw some chemical structure in this Avogadro software. So in order to draw the chemical structure, so this draw tool should be selected, and once you select the draw tool here, that the tools it will be appearing, the elements it will be here. So in this elements, hydrogen, carbon, nitrogen, all the chemical elements it will be shown. By default carbon is selected, and by default single bond order is selected. Okay, and it will be adjusting the hydrogens. So everything. Now you come to that main window and you place the cursor here. Carbon is selected. I think I'm having a little bit trouble with my mouse. Okay, so okay, once you click it, that carbon atoms it will be added, and you could add again the control is set for redoing that operation. Again the same problem with my mouse. Okay, so totally I have deleted the structure. Okay, so like this. Then you select this navigation tool, you could rotate it, and with that right click you could move this. Now let me perform that optimization, and you could see how okay the structure is optimized here. Start. See, so I didn't change the bonds here. See, now D is 0. Okay, and the optimization energy is shown here. Your structure is optimized. Okay, automatically the calculation is stopped. You stop it, then go to the tools again. Now I am going to change the bonds. So this is a double bond. Now you could see automatically the hydrogens are adjusted, and this is the double bond, and this one is a double bond. Okay, perfectly you can draw this. Once again, if you try that optimization tool, see clear one structure, you could draw it here. You could change the atom colors, everything with the help of that selection tool. You could change the color. Okay. You could change your atom color, whatever the color you need it. In case if you want to change this color, you could change it. A beautiful drawings can be drawn with the help of this Avogadro. So now let me draw some nanotubes. So for that build a nanotube builder. Okay. So the length you have to select. Let me take a unit length. For nanotechnology people, so okay, mostly understood the concept of this N and M and everything, the periodic units. So now I am building this. It is built. Navigation tool, let me select. Beautifully, you can build a nanotubes, a nanostructure, so you can draw it here. Okay, so now simple. Okay, some chemical structures you draw it. Optimization is there. So see how beautifully your structure is optimized. And finally, once you draw your chemical structure, you have to go to that save as. Okay, and you can save your file in any of these formats. Straight away you come to that extension. Let me tell okay how to do the Gaussian input software with the help of Avogadro. So you have to select the Gaussian input. Title example 1. What type of calculation you are going to perform here? Whether are you going to calculate the single point energy or the geometric optimizations or the frequency calculations you are doing. So once you select it, okay, here you could check that this is SP single point energy, geometry optimization OPT, and frequencies. Along with that optimization, frequency calculation it will be carried out. And which theory you are going to use it, whether you are going to use B3LYP, okay, or you are going to use the model AM1 PM3, okay, all these models can be selected with the help of this theory. And what type of basis sets you are going to use it, that can be selected using this. And the charge, multiplicity, okay, the output, format, everything, the checkpoint file, whether you are going to save it or not, that all these things can be done with the help of this. And once you press it, and it will be generated. Where do you, okay, do you want to save that Gaussian input file? That you can save it here. File is saved. Close. So regarding Avogadro, that's all, friends. Okay, so you can draw the chemical structure beautifully. You could do the optimization and you could perform okay, so many operations with the help of this. And finally, you could save it for DFT calculations as the Gaussian input files. I think you could understand the concept here. So let us move to that the next software. So I have opted for live chat, okay, in the invisible mode. So tomorrow let us have all type of discussions. Okay, you can ask your queries and everything. Then is GaussView, which is a commercial software with a lot of features available to do the DFT calculations. It is the front end. That means in order to produce okay, what type of things can be done with the help of this GaussView. It is explained in this simple diagram. So it will initiate and control the Gaussian jobs. It will be calculating. Initially, it will set up the jobs, and from that, it will calculate by okay interconnected the Gaussian software. It will examine the results. You could visualize okay in the graphical form. It will import so many types of molecules onto that main window. and even it will build and modify all the types of chemical structures. So all the features are explained with this a simple diagram itself. One of the mostly used commercial software to perform a DFT calculations. Okay, and this software GaussView and as well as the Gaussian both are interlinked and will perform the DFT calculations. So let us go to the GaussView software. Once you download, okay, and you install the Gaussian software in your system, when you open, okay, the window, it will be appearing like this. There are two windows it will be appearing. One is the main window, another one is that the secondary window, the molecule window. So in that main window, okay, so the options: file, edit, tool, builder, view, calculate. So in this calculate tab only, okay, we will be connecting that Gaussian software here, and Gaussian calculations it will be performed, and the results can be visualized and examined with the help of this results tab. Excuse me. I think I am not boring you, and with the help of this lecture, I suppose you are learning certain things. When I was doing research, okay, so there are very few peoples are there to help. After that only I realized, okay, researchers and students, those who are interested in research, need certain guidance, and they need some initiation to carry out their research. So because of that only I have started this YouTube channel, that amazing knowledge, that by Dr. Ravikumar Chandrasekharan, that's me. And I have uploaded so many videos, okay, related to that DFT, molecular docking, okay, and bioinformatics, how to perform that ADMED. And still I'm doing some of the molecular dynamics videos also, and planning to, okay, conduct the workshops based on molecular docking and molecular dynamics, even in the crystallography part also, okay, planning to organize some workshops. So we'll see. And I thank all the people, okay, who responded to my invitations and attending. Right now nearly about 600 people are watching this live. I'm so happy. So in this Gauss view, the main three important tool buttons are these three. Okay, this is the element fragment button. Once you press this, all the chemical element fragments will be appearing here. By default, carbon is selected. So when you change it nitrogen, you could see in that main window, nitrogen will be oxygen, fluorine, chlorine, whatever you select. And for this element fragment, the other fragment buttons are given here. This is the terminal chlorine, okay, and this is that linear chlorine, and so on. So you select as carbon here. Once you select it like this, this is that element fragment button. When you press that ring fragment, all types of rings it will be appearing. This benzene is by default. So you select this ring fragment. See, all type of ring elements are appeared here. Thiophene and furon. Furon. Okay, and all these things can be done. Now this is the OR group. So all type of OR group fragments can be inserted with the help of this button. These three are very important tool buttons, and another one is the builder. So with the help of this builder only, we are going to draw the structure here in this GaussView software. So for that, I'm going to activate the builder tool. So for that, you have to go to view, and from there the builder. So builder is activated. It is like this. So again the same buttons are here, that element fragment and that ring fragment, and as well as the OR group fragment is here. The custom fragment buttons are also here, and even you could add the biological fragments. Okay, so many biological fragments are here, like amino acids and nucleosides and other all type of amino acids you can add as a central fragment or a terminal fragment, okay, or carboxyl terminal fragment. So all these things could be done here. So now what I'm going to do is I'm going to select that ring fragment. So in that ring fragment, okay, by default I'm going to select the benzene. So come to the secondary window, click on anywhere, benzene is added, and again, okay. So now I'm going to add some nitrogen here. So I have selected that nitrogen. This is nitrogen. You can change it. Or again, still you want to add some R group here. That R group you can add it. You can select it here. That R group is added. Select wherever you want. You could add it. Select. Don't think about the chemistry here. Okay, just the structural drawing I'm performing. I'm not teaching you chemistry here. So like this, you could add it. Still, you could extend your structure. See, now I'm going to add the thiophene. Okay, I have added. You could maximize, minimize. Okay. So now some of the structures are not visible. So to make it visible, what you have to do in the builder tool, so you have to click this button. Okay. So this is nothing but okay, centralizing all the structures. See now, with the help of your left button of that mouse, you could rotate it and you could see. And with the help of that right button, okay, you could enlarge and you can zoom in and zoom out. Okay, that you could see like this. If you have enlarged it like this and go to that center button, automatically it will be centralized. Okay, see now. This moiety is in one direction, this is in another direction. Like in Avogadro, okay, auto optimization. Okay, here also we could clean. In Marvin sketch also we performed that cleaning that structure. Okay, for this also we can do this cleaning that structure. For that, this is a brush tool. Okay, that cleaning brush tool. Okay, it is given. So once you press it, now you could see automatically the structure is clean. Now you could see. So this is that a simple chemical structure drawing with the help of this GaussView software. You could draw, and you can extend to that the complex structures. Okay, as per your interest, you can perform this. And for publication purpose, you could change the colors and the types, everything. See here, let me show you how to change the bonds. Okay, so for this, this button is useful in builder tool. This is modifying that bond. Once you press it, okay, you have to select two atoms. See, two atoms selected, immediately the another one pop up it open. So in that pop up window, it will be asking, okay, which type of bond you are going to choose. So already say double bond I am going to select here. See, double bond, immediately it is changed. And this single bond and these two double bond, and again so on, like this you could change it. So you could change it in this way. Okay, so this is to modify the bond. And what is the use of this button that I will explain now? This is to modify that angle. So how to modify that angle? Let me explain. So you have to select three atoms. When you select the three atoms, then automatically, okay, another one pop-up it will be appearing. So with the help of this pop-up, you can modify that angle. See, now you could see the angle is modified between the two moieties. Okay, so you can choose that atom one is the rotation group or a fixed group. When you keep it a fixed, that atom one is fixed, only 2 and 3 are rotated. Okay, and atom 2 is a translate I have given. Translate group or translate atom. Okay, it is given. This is translate atom. Translate group means, okay, it will be like this. It is a rotate group, rotate atom, only atom is rotated, not a group, and fixed like this. You could once you do this, press OK, then again you clean your structure, automatically your structure is clean. So like this you can do it. And this one is used to change the dihedral angles. So in order to change that, you have to select 1, 2, 3, 4 atoms. Once you select that 4 atoms, then automatically here you okay, another pop-up window is appeared, and you can change the dihedral angles here. See now how beautifully you are changing the dihedral angles. Atom 1 you can keep it as fixed, only this you could change. Or atom 2 is rotate group and atom 4 is fixed, this will be rotated. So you could modify in any way. Clean the structure. And this one is the enquiry tool. Okay, using this enquiry tool, you could select any 2 atoms. Automatically, that the bond distance between these 2 atoms will appear here at the bottom of your screen. Okay, and when you select the 3, then that angle between that it will be appearing. When you select 4 atoms, dihedral angles it will appear here at the bottom of the screen. So that is that enquire button. Okay, and here with the help of this you could add the valence hydrogens, and with the help of this you could delete the atom. See now I am going to delete this hydrogen atom. I have deleted. Okay, this totally I am deleting. Okay, I have deleted this like this. This is deleting. And this one is invert about that atom. So I am going to invert it about it, or in this way you select it and invert. You could perform. It will be inverted about that atom. That could be done. And these 3 are selection tools. Okay, so you could select the atoms by clicking, or rectangular selection, or okay, brush selection like this. You could do with the help of these tools. So this builder option is much useful. Okay, to draw the chemical structures. See, you could draw the chemical structure. So now let us assume this is the chemical structure we have drawn. Okay. And how to save this for Gaussian calculations, DFT calculations. Okay, so for that you go to the file, okay, then save. So to save it will be asking file type, Gaussian input file. Okay. So everything it will be asking. Some example to save. Save. Okay, example to GJF Gaussian input file. It is saved. Now using that calculation tube, we will perform the Gaussian calculation, DFT calculations. That okay, we will see it on tomorrow. Okay, so here I think these 3 softwares are much useful for us. Okay, to generate the input files for Gaussian software, and based on that we can perform the DFT calculations. And in my channel, YouTube channel, you could see okay some of the related videos of this generation of DFT software. You could go through that. Okay, and if you have any doubts in the comment section, okay, you type your comments. So definitely I will clarify your doubts. I hope you enjoyed this session, and this will be useful for you as new researchers, and many graduate students are here in this YouTube live. Okay, so this is the basic training. So once you understand the basic part of doing the simulation thing, then you could learn the advanced concepts. So most of us are much strong in the theoretical part, but if a laptop is given to us, we don't know how to do all the chemical simulations. But we are more strong in the theory. If you give a pen and paper, you will do all type of okay equations and chemical calculations, and you will give it. But when you are asked to do some simulations with the help of computer, there we will get a little bit okay upset. So nowadays these computer softwares are mostly popular, and we should learn it. Okay, and it will simplify our work, and it will also provide the accurate results. So learning, okay, is the endless process. Keep on learning. So again on tomorrow sharp by 10 a.m. okay, we will meet it, and tomorrow I will explain how to perform DFT calculations, okay, using the Gaussian, and also we can analyze the output files. Okay, from the Gaussian output files, what are the properties we could, okay, analyze it. So everything we will do it tomorrow. Okay, so thank you friends, thank you for attending this YouTube live online training program on density functional theory. Thank you once again. So let us meet tomorrow. Thank you.